Safety and risk analysis. Okay, presented by Golden Ashwini. On completion of this video, students will be able to explain what are safety and risk and also explain the risk analysis. Safety and risk. One of the main duties of an engineer is to ensure the safety of the people who will be affected by the product that he designs. The codes of ethics of the professional engineering societies make it clear that safety is of paramount importance to the engineer. The engineering codes of ethics show that engineers have a responsibility to society to produce products that are safe. Nothing can be 100% safe, but engineers are required to make products as safe as reasonably possible. Thus, safety should be an integral part of any engineering design. Safety and risk. The term of safety and risk are interrelated. It is amazing to know that what may be safe enough for one person may not be for someone else. It is because of either different perceptions about what is safe or different predispositions to harm. Risk. Any work which might lead to harm us and is not considered safe can be understood as the risk. According to a popular definition, a risk is the potential that something unwanted and harmful may occur. According to William D. Rowe, potential for the realization of unwanted consequences from impending events. Acceptability of risk. Lawrence, in his definition, observed safety as acceptable risk. Let us relate to this and further see the definition by William D. Rowe. A risk is acceptable when those affected are generally no longer apprehensive about it. Influential factors that lead to such apprehension or whether the risk is accepted voluntarily. The effect of knowledge on how the probabilities of harm or benefit are known or perceived. If the risk or job related or other pressures exist that cause people to be aware of or to overlook risk. Whether the effect of a risky activity or situations are immediately noticeable or close at hand, whether the potential victims are identifiable beforehand. Okay, next, what is the risk benefit analysis? These risk benefits are based on the perception of probable gain and probable loss. Risk analysis. The study of risk analysis covers other areas such as risk identification, risk analysis, risk assessment, risk rating, suggestions on risk control, and risk mitigations. In fact, risk analysis can be deeply discussed with a view on risk management study. The risk management study also includes residual risk transfer, risk financing, etc. A stepwise risk analysis includes hazard identification, failure modes and frequencies evaluation. Failure mode and frequencies evaluation from established sources and best practices. Selection of incredible scenarios and risk. Fault and event trees for various scenarios. Consequence effect calculations with workout from models. Individual and societal risk. ISO risk contours risk reduction. The risk we generally face can be reduced to the great extent by proper analysis with steps. That's all mentioned below. Define the problem, generate several solutions, analyze each solution to determine the pros and cons of each, test the solution, select the best solution, implement the chosen solution, analyze the risk in the chosen solution, try to solve or move to next solution. Okay, next we need to know about the relationship between risk and the cost of manufacture. So it is always a great challenge to engineers to balance quality and safety against cost. In general, engineers' tendency is to design and produce high quality products, but the business managers tend to keep the cost down. Okay, so therefore it is necessary to understand the relationship between safety, risk, cost and the price. So the primary cost may be have two elements: primary cost product and secondary cost of product. Primary cost of product we here mention as a P, and the secondary cost of product here we mentioned as a S. So P includes production cost and the cost of safety measures involved. S includes costs associated with warranty expenses, loss of customer goodwill, litigation, possible downtime in the manufacturing process. So this graph actually shows the relationship between risk and the cost to manufacture. And also, a stress on low risk and high safety leads to high primary cost and lower secondary cost, and vice versa. So the total cost is the sum of primary and secondary cost of product, and the total cost of minimum at point M. In the figure we show it as M, where the slopes of the primary and the secondary cost curves are equal in magnitude but opposite in the direction. Therefore, it is the event that both low risk and high risk product are costly. The optimal total cost M occurs in between low risk and the high risk region. Thank you.